The chemical and metallurgical properties of this iron ore are critical to both the seller and the buyer. This gold-bearing ore is sampled in the pit prior to blasting and in the crushing and processing stages, ensuring optimum gold recovery is achieved. The mining industry is not alone in its need for accurate sampling of bulk commodities, but unlike other industries, it's essential to almost every stage, from exploration and mining through to production and shipping. Inaccurate sampling at any stage of the process can have a major impact on bottom line profit. Automated sampling delivers exact and consistent sample increments, providing a true representation of the quality of the bulk commodity, which is difficult to achieve manually. Automation also greatly improves safety on site by protecting operators from the difficult and hazardous task of taking and preparing samples. When operators are carrying out checks or removing samples, ergonomically designed equipment with major hazards removed deliver a better work environment and improved safety conditions. Here at its modern premises in Western Australia, ESSA employs more than 100 staff. The company specialises in the design and manufacture of proprietary sampling and sample preparation equipment for the international mineral and mining industries. Good sampling practice is governed by the use of proven system designs and procedures which comply with internationally accepted principles. ESSA's reliable, low-maintenance samplers and engineered sampling systems meet or exceed these international standards. Equipment design and manufacture takes place in-house to meet ISO 9001 quality control standards and to enable the flexibility to customise products. At this port, located in Western Australia's Pilbara region, ESSA has designed and installed an automated shiploader sampling system for iron ore. It uses ESSA's innovatively designed sample cutters and collectors to sample material from the large iron ore streams. The objective is to reduce the primary increment in an unbiased way to a size that is manageable for transport to the laboratory without compromising sample integrity. ESSA designed, manufactured and installed the equipment here to ensure that the final sample presented for laboratory preparation and analysis will be truly representative of the original material. This has big benefits for business. At certain Pilbara iron ore ports, the customer has agreed to accept the sampling results at the port of export as final. This load port final agreement is based on trust between supplier and customer that the sample taken is correct. This requires trust in the equipment and processes being used. So, how does ESSA ensure a true, representative sample is achieved? ESSA designs, manufactures and installs its sampling systems to meet or exceed international standards. A typical configuration of a plant sampling system is a primary cutter, followed by at least a secondary cutter and a sample receiving device. Design of the primary and secondary cutters is crucial to achieving accurate and representative samples. All particles must have an equal opportunity of being sampled without any loss or contamination. Taking a sample from a falling stream is the preferred way to adhere to these fundamental sampling principles. ESSA has several linear cross-stream samplers to suit a variety of applications. The ESSA range of linear samplers work by moving across the entire width of the material flow, cutting the falling stream of ore from the end of a conveyor belt. They are the ideal sampler for ship loading conveyor belts. ESSA pioneered and developed ball screw direct drive sample cutting to ensure optimum accuracy and reliability from sampling systems such as this one. In keeping with the fundamental principles of good sampling practice, the cutter spoon intercepts the entire stream of material. The design combines the precision of an electric drive with the mechanical advantage of the ball screw, ensuring constant and uniform speed while in the ore stream. At the top of the discharge spoon, the cutter aperture has straight, sharp blades which cut the sample as the spoon moves through the material stream. Sample material is discharged below to a chute and feeder conveyor. Good sampling practice dictates that the cutter spoon opening is constant and that the capacity of the spoon is sufficient to collect and discharge the complete sample. During the process, there is no loss or contamination of the sample. In addition to the ball screw linear sampler, ESSA offers two specific linear samplers designed for large tonnage sampling. The belt drive linear sampler is a large stroke sampler driven by a toothed drive belt. Like the ball screw sampler, it's positioned above the conveyor discharge point with the cutter mounted below. Where the sampler has to be mounted below the discharge point, a synchronous belt drive sampler is used. A single electric motor drives two synchronised toothed belts located either side of the ore stream. This allows the sampler drive and cutter to operate on the same plane across the falling ore stream. This design is suited to high tonnage shipment conveyors. These belt drive samplers adhere to the same good sampling practices demonstrated by the ball screw drive. Primary sampling can produce samples of up to 1 tonne or more. Additional stages further reduce the sample using linear or rotary samplers. A Vezin rotary sampler can be used in secondary, tertiary or even quaternary sampling. The technique employs radial cutters that rotate through the entire falling ore stream. Each cutter collects samples as it passes through the ore stream. The cutter must pass perpendicular to the sample stream, and it must pass a sufficient number of times to ensure a representative sample is taken. This process of sampling and subsampling is repeated until a representative sample reaches a weight manageable to an operator. Final samples range from 5 to 10 kilograms. Where it's necessary to collect more than one sample over a period of time, a rotary sample collector, or RSC, is used. The 8-container RSC is an ergonomically designed collector. It allows the operator to easily remove the samples to be transported to the laboratory for further preparation and analysis. Buckets of samples collected over a period of time are kept sealed and contamination-free during the complete cycle. The automatic sealing platform prevents dust ingress and moisture loss. ESSA takes advanced automated sampling systems one step further. Many leading commercial laboratories, port loading facilities and mine sites embrace robotic systems as their preferred method of sample preparation and analysis. At this port, dual robot cells process samples directly from the secondary sampler. As the ore is being loaded onto the ship, samples are constantly being analysed for moisture content and size fraction in accordance with international standards. A third sample is split off for chemical analysis in the laboratory where once again ESSA's automated solutions ensure optimum accuracy and efficiency. Accurate and consistent analysis teamed with rapid turnaround provides this exporter with quick payment many days before the ship has reached its destination port. ESSA's sampling systems deliver on accuracy, on speed, on reliability and on safety, all of which is good news for your profitability. With over 15 years' experience in supplying sampling systems to mines and ports in Australia and Asia, handling a wide range of commodities, ESSA now provides global support and expertise. ESSA's operations in Australia, South Africa, Europe and Brazil give you ready access to world-class sampling solutions. If best sampling practice is pivotal to your business, depend on ESSA's engineered representative sampling systems.